Hello everyone, welcome back to another video, and this is a special one. It is an entire maths lesson for free. It's straight from our website. We upload 4 lessons every single week covering maths, English, verbal and non-verbal reasoning, and this is one all about the 4 operations. How to add, subtract, multiply and divide with any number, whether that's decimals or not, whether it's more than 2 numbers you're adding and subtracting, short multiplication, long multiplication, division strategies. It's all in this video, so watch it. Practice. Hopefully it helps you. I'll link the homework down in the description, and I'll also link a place where you can go, that's our website, to sign up for a 7-day free trial. That means you'll have access to 16 lessons, including this one and all of the accompanying homework. So guys, let us know how you find it down below. Like this video and subscribe for more content like this in the future. Let's dive straight in, because I was really excited for this lesson, because arithmetic is something that's so important and you will do in school so much. And I know that our lessons really focus on the trickier stuff, grasping those trickier concepts and then having to go at test style questions. But this is really important. So what better time than during our half-term bonus lesson to go over some really key arithmetic. And what we mean by this is the 4 operations: addition, subtraction, multiplication and division. And we'll look at all of them in this lesson, but we'll look at them, not the simple things. I'm not going to ask you to do 25 plus 32. I'm not going to ask you to do those kinds of questions. We're talking about decimals, how to work out things quickly. Hopefully it's going to be a really helpful lesson for you. So let's take a look at the first addition. I want you to have a go. Pause the video. Can you do that? And then I'll show you the tricks and the traps. So this is decimals. This is a classic trick. So 450.1, and it might be really tempting to start writing the 1575 and just matching that up. No. When you're working with decimals, look at the decimal places. This has 1 decimal place. This has 2. These digits don't just line up. But I will tell you something that always lines up. It's the decimal place. So just put that in straight away. That's my number 1 tip when we're adding decimals with different decimal places. Put the decimal in and then fit the numbers around the decimal, because you will not go wrong at this point. So we're adding these together. We've got some blanks. This is where your choice comes in. I sometimes like to just fill my blanks with placeholders, just so I don't get confused. It's up to you. You don't have to. So let's do some addition now. It becomes quite simple. 0 plus 5 is 5. Here's 8. 5, 6, and 4. So the answer is 46,585, right? No, that's wrong, because this decimal place has to stay where it is. Put that decimal point in down here. Really vital. It completely changes your answer otherwise. So the answer to this question was 465.85. Taking a look at this one, it's your go. I want to see what your technique is. Then I'll show you some ideas and tips and hints. A really key thing that some children miss out sometimes is that you can add more than 1 number at a time. So with addition, I like to just line them up. 495, and then we're going to have 34. And think about this 6.7. Where would the decimal point go here? Well, it would always go after the ones column. So you can label that ones, tens, hundreds. This would be tenths. We can do it with a small t, or the fraction tenths. And then 6.7 would be 6 ones, 0.7. And again, you can just add these up. When you're using addition, you can add up multiple numbers at once. So let's look at the tenths column. I'm going to put zeros in just to hold the place. That's just 7 tenths. Put the decimal down. 5 plus 4 plus 6. Look for number bonds. 6 plus 4 is 10. Now it makes it easy to add to 15. 9 plus 1 is 10. Makes it easy to add to 13. 4 plus 1 is 5. The answer to that question, well done if you got it, was 535.7. So just to recap so far, line up your decimal places. If you've got more than 2 numbers to add up, you can do it in the same column if you're confident. Oh, just try and do this yourself. Okay, think about what I just said and just think, actually, is that the best technique in this situation? I wonder if you can find a more efficient one. Have a go. So based on what I just said, you might be thinking, oh, I'll just put it into a really long column addition. And that would get you the answer if you're accurate with your mental arithmetic. However, I want you to take a look at this now and just think, how can I add these numbers up quickly and efficiently? And you're looking for bonds. Now look at 27 and 73. That is a number bond to 100, and it's vital. We talked about this in the starter. You need to be really confident with 2 numbers up to 100, because what I can do now is cross these out and I can replace it with 100. Okay, now let's look elsewhere. 11 and 5 and 4. It might not look like a number bond to you, but what's 5 plus 4? It's 9. And 9 plus 11, yes, I can get rid of these 3 numbers. They add up to 20. So I've got 20 plus 100. Plus 50 is the only thing that's left. That's something we can do mentally. 20, 150. No need to write down long calculations, adding up 7 plus 5 plus 1 plus 4 plus 3 plus 0 and exchanging over. No, look, sometimes looking for those shortcuts, that gets us to the answer really, really quickly. So there's my next technique. Look for number bonds. And then finally for addition, what I'd like you to do is have a go at all three techniques. So these three are what we just talked about. Pause the video, see if you can get me an answer for every single question. Okay, so here we had to line it up, 450.1 and then 15.75. Look at my decimals. I'm going to put placeholders in and I'm going to put a decimal for my answer. 5 and 8 and 5 and 6 and 4. So having that ability to add numbers up quickly is vital in 11 plus, guys. So do practice that. Something you do at home really easily. Get a dice, roll them, add them up, practice and practice and practice. Next one here. Let's take a look for any bonds that we can find. 66 plus 34, that's 100. 58 plus 42, that's 100. And then we just have 5 left over. So that's really easy, 205. Look how quickly we solved it because I'm confident with my bonds. If you're not, something to practice. And here at the bottom, 34, I'm just going to line these up now because there's decimals and it could get confusing quite easily. And 6.7, not in the tens, Mr. Price. Put the decimal, put the decimal, put the decimal in the answer. Placeholders, just because I like them. We have 7, 6 plus 4 is 10, plus 5, 15, 9 plus 1 plus 3 is 13. And then we can whack down there 5. The answer is 535.7. Superb. That's addition. Hopefully nothing too tricky there, but always good to practice and remind yourselves of these techniques. You guessed it, subtraction. Try and answer that and see what you get. Okay, so again, number of ways we can do this. You could literally write down 15.0 and then take away 6.8. Now this we can just use standard column subtraction. We get a 2 there, bring down the decimal, remember. 4 take away 6 we can't do, it just becomes 14 take away 6. And that's 8, so the answer is 8.2. Another way to do this, some people like to partition the 6.8. And they do 15 take away 6, that gives you 9. And then you've got 9 take away the 0.8. And if you're really confident with taking away less than a whole, you know that number bonds 0.8 and 0.2 make a whole, so it's going to be 8.2 as the answer. That's if you're more confident, you can do it more quickly. If you're not sure, just jot this down quickly and you'll get the answer right. 2004, take away 1986. Before I say pause the video and have a go, you could just put it into column subtraction. Of course you could. Can you think of a quicker way to do this? So as I said, you could do this. 2004, subtract 1986. Now here's the problem. 4 take away 6 we can't do. We don't have any tens. We don't have any hundreds. We only have thousands. And as soon as we start to exchange past more than one column, it becomes messy. We become prone to mistakes. Now this will still work if you're confident. That's 8. 9 take away 8 is 1, 0, and 0. So the answer is 18. Now here's the thing I wanted to teach you. Do you notice something about these two numbers? Well, yeah, look at the answer. They're only 18 away. So what you can do is think of it like a number line, because subtraction is the same as finding the difference. So 1986 and 2004, they look like years to me, so I'm saying them like years. And then we can think 86, how far away from 2000 are we? Well, we can add 14. It's all about those number bonds to 100. Knowing them is going to help us with shortcuts. So that gets us to 2000, and then 2000 to 2004 is just 4. 14 plus 4, it's the same. It's 18. All about what works for you. So have a go at this question. It's similar to one we talked about with addition. Can you use column subtraction, line up the digits and the decimals, see if you get an answer? So I hope you've noticed that we haven't actually done very many very simple subtractions, because what's the point? You guys will know that technique by now. 501.4. Put the decimal in first, my biggest piece of advice, because now we can fill around the decimal. And notice how they're kind of just off, aren't they, by 1, these digits, which is absolutely correct. Put some placeholders in, and then we're going to subtract. 0 take away 7 we cannot do. So we exchange. 10 take away 7 is 3. Again, look, 3 take away 5 we can't do. We need to be really confident with exchanging. Look how messy this gets. 13 take away 5 is 8. Put the decimal in. 0 take 7 we can't do. We've got no tens. We have to go to the hundreds here. So we have to be confident with exchanging. Sometimes there are shortcuts. Sometimes we've just got to do it. Now we can exchange from the tens, and we get 10 ones here. 10 take away 7 is 3. 9 take away 6 is 3. 4 on its own, take away nothing, is just 4. The answer to this question, 433.83. You have to be so confident with this method, this technique, and you have to be good at lining up your numbers. Really good practice here. What about when you've got to subtract two numbers at once? Because remember I said if we're adding more than two numbers, we can just put them all in the same column. That does not work with subtraction. How can you do 9 take away 7 take away 5? That doesn't quite work, does it? No, kind of a middle step. Do you know a way to do this efficiently? Now the thing with subtraction is going to be 2 steps. Now you could do 4,583 take away 675, get an answer, and then take it away again. That's fine. That will get you the right answer. What I like to do, if I'm taking away 2 chunks, I like to find out the total that I'm subtracting. So I actually have to add them together. If I do 675 plus 325, that is the total amount that I will take away at the end. So 5 plus 5 is 10, 7 plus 2 plus 1 is 10, 6 plus 3 plus 1 is 10, and now look why this might be more efficient sometimes. Instead of taking away 675 and then taking away, let's think of it like this, and then taking away another 325, if I just group it together, that's 1,000. And I can just take away 1,000 in my head. What's 1,000 less than 4,583? 3,583. And that's the answer. Now you could have sat there and done take away 675 and then loads of exchanging and got an answer, and then take away 325 and then lots of exchanging and got an answer. And that's fine. But what we're trying to do in this 7 plus, we're trying to save time, trying to be efficient, and understanding that we can just add these 2 chunks together and then take it off. It saved us loads, guys. It saved us loads of time. So you know what's coming now. You've got 4 questions. We've talked about a lot of techniques. If you can't remember them, rewind the video and watch them. Why not? But have a go at these 4 questions. Can you get 4 answers that are accurate? Okay, let's look at the top one, 25. I'm going to put the 0.0 in straight away, take away 7.8. I like this technique. 0 take away 8 we cannot do, so we can just exchange over. 10 take away 8 is 2, put the decimal in. We can't do that, so we exchange. 14 take 7 is 7, and the 1 is left over. So the answer here is 17.2. 2003 to 1997, I'm going to use the number line method. 1997 to 2003. 1997 to 2000, that's just going to be plus 3. And then obviously from 2000 to 2003, that's plus 3. We have 2 chunks of 3, so the answer is 6. Look how quick that method was. Really, really good. 46.2, subtract 3.97. I've matched up the decimals. I'm going to put some placeholders in. Why not? Now I'm going to subtract them. 0 take 7 we can't do. So it's 10 take 7 is 3. 1 take away 9 we cannot do. Do some exchanging. 11 take away 9 is 2. Put the decimal in. 5 take away 3 is 2. 4 on its own is just 4. So here we have 42.23. Lovely. And now at the bottom, I'm going to add these 2 up together. So 378 plus 122 to get the total that I'll take away at the end. 8 plus 2 is 10. 7 plus 2 plus 1 is 10. 3 plus 1 plus 1 is 5. 500. And actually, if I swap this for just taking away 500, I can do it in my head. Look at the hundreds column. There's 8 hundreds. Take away 5 of those hundreds. We're going to have 3,355. These techniques save time. I promise you. It's worth putting time into mental arithmetic, spotting the patterns, and looking at different techniques. I promise. Multiplication. This is just a simple short multiplication, but it's testing your times table knowledge. It's the 8s, the 6s, the 9s, and the 7s. Have a go. Now, I don't really have any special tips for this. You just need to know how to lay this out. You would have done this in school for years for now. But the thing I'm highlighting here really, guys, is you've got to put the time into your times table practice. 9 7s are 63. 7 6s are 42. Plus 6 is 48. 7 8s are 56. Plus 4 is 60. Now, I have got to the point where I can do it that quickly because I know my times tables off by heart, and I can add 6 and I can add 4. And that's important because look at what we're exchanging. So you guys have to develop that. If you're not quick at adding 6 to any number, practice it. Pick a random number, 47, add 6. How quickly can you add 6 to that number? What are your strategies? All of these things, these additions, these mental additions here, you can see how they come into everything we do with the 4 operations. And the quicker we get these foundations, the more time we're going to get in the real 11 plus paper. So the answer there is 6,083. How about when we have a decimal and we're multiplying by a number? Why don't you have a go at setting this out and see how you get on, and I'll show you after. Now, it's actually no different to what we've just done. So lay it out, 56.31. Make sure that decimal is really clear. Multiplied by 5. So let's go in here and just treat it like a normal short multiplication, ready? 5 ones are 5, 5 threes are 15, 5 sixes are 30, plus the 1 is 31, 5 fives are 25, plus the 3 is 28. And the last thing to do, have you seen it? Probably shouting at me right now. The decimal! That's it. As long as you remember to line up your decimal place, the answer is right there. It's 281.55. The technique's the same. You still need to know your times tables. You still need to be able to add on a single digit number to any random 2-digit number. Really important. Oh, you'll be learning this in year 5. Long multiplication. Do you know how to do it? I'll show you how to after, but it's important that you can. Let's take a look, shall we? Now, this one we need a bit more room. So I'm going to start up here. 438 multiplied by 32. Now, what we're about to do is split the 32 into 30 and 2. So what's 2 lots of 438? And what's 30 lots of 438? And if we add them together, we'll get the answer down the bottom. So firstly, let's do the 2 lots. 2 times 8 is 16. 2 times 3 is 6, plus the 1 is 7. 2 times 4 is 8. So that's 2 lots of 438. Now we need 30 lots. And here's the thing about 30. 30 is the same as times 10 times 3. Now we know our 3 times table. So how can we times something by 10? We put a placeholder in. And now I can just focus on timesing by 3. 3 times 8 is 24. Putting a 2 down here. 3 times 3 is 9, plus the 2 is 11. 3 times 4 is 12, plus the 1 is 13. And now I have 2 numbers, 30 lots and 2 lots. So to find 32 lots, we just add them up. 6, 11, 10, 4, and 1. 14,016 is the answer. That's long multiplication. You need to be confident at doing that. You'll practice this lots in school. And do you know what, guys? These are really easy things to practice because you can just pick random numbers and then put it in the calculator and check your answer. Something you can do so easily at home whenever you like. So you know what's coming. Can you practice the 2 short multiplications and the long multiplication at the bottom? Excuse me, and I will show you how to do it after. Okay, let's take a look. 967 multiplied by 6. Again, did I choose easy times tables? No, obviously not. 6 times 7 is 42. 6 sixes are 36, plus the 4 is 40. 6 times 9 is 54, plus the 4 is 8. So we have 5,802. Next one, again, it's 5. Sorry, I've started with the 5 for some reason. It's a 4-digit number, but it doesn't matter. We can still use short multiplication and just make sure we whack down that decimal at the end. 6 times 4, that's 24. 4 twos are 8, plus the 2 is 10. 4 fives are 20, plus the 1 is 21. 4 threes are 12, plus the 2 is 14. Bring that decimal down. The answer here is 14.104. And long multiplication, let's just make sure we're really confident in setting this out. Remember, we're multiplying by 46. So what we're really doing is multiplying by 6 and multiplying by 40. Let's do the 6 first. 6 fours are 24. 6 threes are 18, plus the 2 is 20. 6 twos are 12, plus the 2 is 14. Now at the bottom, put the placeholder in, because now we can concentrate on the 4 times table. 4 fours are 16. 4 times 3 is 12, add the 1 is 13. 4 times 2 is 8, add the 1 is 9, and we can just add these up now. 4, 6, 7, 10. The answer to this one is 10,764. Really important. Times tables, but something that's equally as important when we're answering these questions, adding a 1-digit number to a 2-digit number. Because look, for example, we worked out here that, let's just say, we worked out up here, 6 times 6 is 36. Can you add 4 on quickly? Here we worked out that 9 times 6 is 54. Can you add 4 on quickly? That's part of the equation. So quick addition, quick mental addition, and times tables are really vital to your multiplication. But you know what that means. We've done addition, subtraction, multiplication, division. Short division, can you work out that one? You have to be able to do that. So let's see what you can do, and I'll show you how to do it if you're not sure. Let's dive in, shall we? This is commonly known in school as the bus stop method, because we write down 736 and we put what looks like a bus stop around it, and we're dividing by 4. And now we start with the hundreds columns. The only time in the 4 operations we start in the largest column. So how many groups of 4 can we fit into 7? And if we wanted to do this in school, I'd probably be getting counters out, and I'd get 7 counters, and I'd be saying, cool, how many whole groups of 4 can I make? I can make 1, and now I've got 3 left over, so I can't make a second group of 4. So this number at the top is how many groups of this can I make? So the answer is 1 with 3 left over, so the 3 goes next door. 33, and at this point I'd be saying to my children at school, do I really want to sit here and count 33? No, I don't. And you know what? You won't have counters in 11 plus paper, so this is where your times table knowledge comes really, really, really handy. How close can you get to 33 in your 4 times table without going over? So you might get used to counting 4, 8, 12, 16, 20, 24, 28, 32. 32 is 8 4s, and we can't get any further. But the question still remains. If I took 32 out, because that was 8 4s, how many did I have left if I actually started with 33? Well, obviously the answer is 1. Okay, so we've got 1 left over here, it goes over. 4s into 16 is 4, and the answer is 184. You need to be able to understand your times tables. You need to be able to count up in your times tables and quickly work out what's left. It's all about that mental addition and subtraction. It's vital. So using the same kind of logic as before with short multiplication, it was the same. We just made sure we put the decimal place in. Have a go of this one. So the decimals don't need to be scary when we're working with these kind of questions. We put in 2.859 all the way to thousandths there. We put the bus stop over. We divide by 3. Okay, so look, got 2 counters. How many groups of 3 can I make if I've only got 2 counters? 0. I can't make any groups of 3. How many are left over? Well, both the counters. So the 2 goes over here. Now we can start using our times tables. How close to 28 can we get in the 3 times table? Well, if you know your times tables quickly, you know that 9 3s are 27. So 9 3s is 9 goes at the top, and there's 1 left over to get to 28. How many 3s in 15? Well, there are 5, because 3 times 5 is 15. How many 3s in 9? Exactly 3. If there are no remainders, you just carry on. You go to the next one. So the answer here is 953, right? No, of course not, because look, decimal was here. Decimal gets pushed up. The answer is 0.953. It's the same technique. You just have to make sure that those decimal places line up. Oh, what about this one? I'm actually going to be quiet and see what you get, and then I'll show you how to do it properly. So you're probably thinking, okay, 3.9, easy peasy. We just put that in. We know we can put the decimal up at the end. 5 goes here. Fine. Okay, 5's into 3. If I had 3 counters, can I make a group of 5? No. How many left over? Well, all 3 of them. I didn't do anything to it. How many 5s can I get into 39? I know my 5s, Mr. Price. I know them. I can do them. There's 7 5s are 35 with 4 left over. 4? Remainder 4? Well, no, that doesn't work. We're in decimals. There's not remainder of 4 things. It's not quite right. We need to continue this calculation. We need to put the 4 here. But we don't have anything next to it. What on earth is going on? Well, have you heard of that placeholder? Yes, of course you have. We talked about it earlier. You can put a placeholder in. So 5's now into 40. We can actually answer that. 5's into 40 are 8. And this answer is 0.78. So when we're working with decimals, if you have something left over, put a placeholder in of 0. You can keep going for as long as you want. Okay, you really can. And the last one here for division, it's using a bigger number that's not on our times table. But my only hint to you is, don't be put off using short division. Have a go. Okay, let's take a look, because this kind of blew my mind when I realized that we could still do this. So 7,875, we need to know how many 25s go into that number. So we can still write 25 here. Now, this is what I was talking about earlier, about 25, something you'd be doing in year 4. So although we don't know our 25 times table, we can count in 25s, right? And 78 is really close to 75. So we can say there are 0 and 7, obviously, and the 7 goes over. How many 25s in 78? Well, there are 3 25s in 78, which is 75. 3 25s in 78, sorry, which is 75. And there's 3 left over. How many times can I take 25 out of 37? Okay, well, think of it this way. This is trickier, obviously, but we can still do it. It's going to be 125. And then how many would be left over to get to 37? So it's just the difference between 25 and 37, which is 12. And then look, how many 25s in 125? Well, let's just continue this pattern. 1 is 25, 2 is 50, 3 is 75, 4 is 100, 5 is 125. It's there. So 525s going to 125. And the answer to this question is, remarkably, 315. So if this division is a number that's bigger, but it's something we can quite easily count in, like 25s or even 50s or even 15s, we can really lay out our 15s and go 30, 45. If you can write out this sequence, you can still use short division. It's unbelievable. So you know what your job is. You've got 4 division questions. I want you to have a go. Okay, let's go. And you would have paused that, right? I've done all 4. I believe you. I believe you. I really do. 984 divided by 8. How many 8s can I make out of 9? 1 8 with 1 left over. 8 into 18, that's 2 8s are 16 with 2 left over. 8 into 24 is 3. This is 123. Simple short division. Next one is still simple short division. We just have a decimal, 65.95 divided by 5. 5s into 5s into 6 go once with 1 left over. 5s into 15 3 times. Put the decimal place in. 5s into 9 once with 4 left over. 5s into 45 and 9. The answer is 13.19. Going down here, this is an interesting one, isn't it? Because it's the one with placeholder. So I put 7.5. I've got room if I need to go. Let's divide it by 4. 4s into 7 go once, and there would be 3 left over. 4s into 35. Well, firstly, let's put that decimal in there. 4s into 35. We can count if we're not sure. 4, 8, 12, 16, 20, 24, 28, 32. 36 would be too much. So 32. That's 8 4s are 32 with 3 left over. Wait. What can I do? Well, you know, don't use a placeholder. 4s into 30. Again, count up if you're not sure, or you just know that 4 times 7 is 28 with 2 left over. You're probably thinking, what? Well, of course, I told you. You can put another placeholder in. 4s into 20, they go 5 times. The answer is 1.875. When you finally get one that has no remainder, you just stop. That's the answer. And at the bottom here, 6,765 divided by 15. Now, what did I say just before? If you can still write out your 15s, 15 plus 15 is 30. Plus 15 is 45. Plus 15 is 60. Plus 15 is 75. Plus 15 is 90. We'll stop there and we'll see if we need any more. 15s into 6 obviously don't go. Exchange over the 6. 15s into 67. Let's see how far we can get. 1, 2, 3, 4. 4 15s are 60 with 7 left over. How close can I get to 76? Really close. Look, it's here. 1, 2, 3, 4, 5 15s are 75 with 1 left over. How many 15s are in 15? 1. We've just done a short division with a huge number 15 and we got the answer right. Guys, you've been superb. So thank you for listening. And I really hope that I've really given you some insight into how to answer the 4 operations questions, the trickier ones, quickly, efficiently, and better, and something for you to go off and practice. And talking of practice, you have a homework because you're watching this video on our website. So down below is the homework. Make sure you click on that and have a go, because all of the different question types we've looked at in this lesson will be explored and you'll get some time to practice them. If you're stuck, watch this video again or watch the homework walkthrough. But as always, it leaves me with one thing to do, and that is to say thank you so much. Thank you for coming to watch, and I'll see you again next time for some more learning. Bye, guys.